So, good day, viewers, learners of chemistry all over the world. From wherever you are watching this video, I send a special greetings to you, and I want to encourage you to continue to watch and to continue to share to other students, and to also encourage people to subscribe, even also to put on their notification button so that whenever a new video is uploaded, they will be duly notified. Okay, please encourage people, and also tell those who want to write exam to watch this video. As you listen to it every time, you have an understanding of what the topic is all about. Okay, for my last video, you can watch it. We talk about the properties and the properties or the characteristics or the features of a gas, and also the kinetic theory of gases, or simply the kinetic molecular theory of gases. Okay, in that video I have made it clear that okay, a gas can exert pressure. Okay, and apart from being exerting pressure, a gas when heated, it can increase the movement of molecule of the gas, and therefore as the movement of molecule of the gas increases, the pressure of the gas will equally increase. And because you are heating the temperature of the container, so as the container receives the temperature, or the heat rather, the temperature is transferred, the heat is transferred rather, to the gas molecules, and because of that, the gas molecule will receive kinetic energy for movement, and the movement will exert so much movement, which will also increase the temperature. That already explains that the average kinetic energy of gas molecule is directly proportional to the temperature that is being applied. So briefly, in this topic of gas laws, we want to look at something. Gas, there are actually four parameters of a gas. Okay, the parameters are the volume of the gas, and because the gas has a definite volume, it has a way of exerting pressure. So the pressure of the gas, and the temperature the temperature also, and the number of moles. Okay, these are these are the parameters that is peculiar to gas molecules. So you look at the first of the gas laws. The first gas laws I will be looking at is actually the Boyle's law. Okay, this um is a popular thing that everybody knows. Okay, what does the Boyle's law state? It states that the volume, okay, of a fixed mass of gas is inversely proportional to the pressure upon it, okay, at constant temperature. Okay, what do we mean? That the volume of a fixed mass of gas is inversely proportional. This is inverse proportionality. Okay, if you put something here without 1 over it, that means directly proportional. So that the volume of a fixed mass of gas is inversely, this is proportionality, so inversely proportional to the pressure upon it. Okay, so far, okay, that temperature remain constant. So this is at constant temperature. So understand that. Okay, this is Boyle's law. And in mathematics, if you apply the rule of variation, you are going to have, you put down this one to equals to the sign of equality, and you put k here, which is your constant. Okay, then you are going to look for your k, which is what? PV. And when you get k as PV or VP, then it means that k will be equal to P1 V1 equal to P2 V2. Okay, so it's either you say P1 V1 equal to P2 V2, or V1 P1 equal to V2 P2. Okay, any of this defines Boyle's law. Okay, any of this now defines Boyle's law. And if you want to show the graphical representation of Boyle's law, Remember that we say V is directly proportional to 1 over P. With this, it means you are going to have V against 1 over P. And because it's directly proportional to 1 over P, we can also say it is inversely proportional to P. Understand that V is directly proportional to 1 over P, or we say V is inversely proportional to P. So if you are using V directly proportional to 1 over P, that means you'll be expecting a straight line graph. Okay, and here you can get your slope and you know what to do there. So this is a graph that represents Boyle's law. But if you are interested in saying that V, please kindly understand what I'm doing, that V is inversely proportional to P. Please understand, this is your mathematical expression that V is inversely proportional to P. Is the same thing as V is directly proportional to 1 over P. I hope you understand what I mean. So if you are using V inversely proportional to P, then the graph you are going to be having will be that you are plotting a graph of V against P. Okay, and when you plot a graph of V against P, in this case you shall be having a graph that will go this way, okay, which define Boyle's law. So the V can be in liter, okay, why this one can be in millimeter of mercury. Different units can actually be given, okay, or centimeter cube or meter cube depending, and this one will also be in millimeter of mercury. Okay, that would be the unit. Okay, this actually define Boyle's law. I hope there is no complication, there is nothing difficult here to understand. So let's quickly go to Charles law. Before I get to Charles law, I want to use kinetic theory to explain Boyle's law. Is what you have here is not something that demands cramming. Look at, they say the volume is directly proportional to 1 over P, or inversely proportional to the pressure upon it. Okay, if you have a piston like this, if you have a container where you have piston, okay, that this thing is a movable piston and there are gas molecule here, okay, if you increase the volume, look at me now, okay, if you increase this volume of the container, look at it, what you have here, okay, let me use this to also explain. So so look at this, the gas molecules are like this. Now the volume has been decreased. So understand, the volume of the container, okay, or the region of space gathered by the gas molecule have been compressed such that the volume is now decreased, okay, and that means as you decrease the volume, what happens to the gas molecule? It will increase the pressure because the movement of the gas molecule will be increased seriously because you are decreasing the volume, then the pressure will be increased. The pressure of the gas molecule will be increased because as you move down the piston, what happens is that the molecule of the gas will now be, the movement of the molecules will be faster, thereby increasing the pressure of the gas. Unlike this, where the volume, okay, has been increased to ensure that the movement of the gas molecule will now be decreased, and as the gas molecule, the movement of the gas molecule is decreased, what you see here is that the pressure will be lowered. Okay, the pressure of the gas will be lower. That means, using kinetic theory of gas from this diagram I've given, it means that as the volume, okay, as the volume increases, okay, that means the pressure of, look at it, as the volume increases, you have increased the volume here, that means the pressure of the gas will be decreased. Okay, and as the volume decreases, because we have applied pressure now, okay, the piston has been reduced to this level. Then as the volume decreases, then that will result to the molecules of the gas to receive enough pressure, okay, so that the molecules of the gas will be hitting one another, okay, will be colliding with one another and with the walls of the container very fast. With that, the pressure will increase. So as volume increases, the pressure of the gas will decrease, and as volume decreases, the pressure of the gas will be increased. Do you understand that? Okay, and vice versa. This explains Boyle's law. Okay, let me quickly go to Charles' law. So for Charles' law, it simply states that the volume of a fixed mass of gas is directly proportional to the Kelvin temperature at constant pressure. Okay, by mathematical expression, we mean that the volume of a fixed mass of gas is directly proportional to the temperature, okay, at constant what? Pressure. Do you understand? Okay, by this mathematical expression, you are required to introduce a constant which will be kt, and if you make k the subject of the formula, you are going to have what now? V over t. With this, because it's constant, it will become v1 over t1 equal to v2 over t2, okay, equal to v3 over t3. That is how it continues, equal to Vn over what? Tn. Okay, so in an examination question where they tell you a constant, okay, that is giving you equals to Vn over Tn, this defines Charles' law. Okay, this defines Charles' law at constant pressure. Okay, so by graphical representation, you are going to have something like this because V is directly proportional to T. You have a straight line graph. Okay, this simply defines Charles' law. There's nothing complex here. Okay, and by kinetic theory of gas, if you have a container where you have gas molecule, okay, gas molecule, and remember this takes the volume, this is the volume, okay, of the gas, and we are talking about in relation to temperature. That means there will be a source of heat, okay, and because temperature heat will be applied, as you increase the temperature of the gas, as you increase the temperature of the gas, what happens? The container will also receive the heat. There will be increase in the temperature of the container, and the gas molecule will also receive the heat that is being transferred. There will be heat transfer, okay, from the source of the heat to the gas molecule. And when the gas molecules receive the heat, what happen? They will gain kinetic energy, okay, for movement. And as they gain kinetic energy for movement, what happens to this piston? Okay, what happens to this piston? This piston will be, let's call it a cover, okay, so that you have a better understanding. It's like a cover. What happens to it on its own? Because the temperature has been increased, okay, and the gas molecules are moving very fast, increasing the pressure of the gas will be very high. So at this stage, it will be moving the piston up. The you have this thing before like this, but right now, because you have heated this molecule, okay, excessively, you are going to have, this thing will shoot up to this level. Okay, okay. So this actually explains Charles' law, telling you that as the temperature of the gas molecule increases, what will happen to the volume? Okay, the volume will also increase. This everything about Charles' law. Okay, just have an understanding and build on the understanding, and then you are good to go in any exam. Okay, then with this understanding, you cannot allow anybody to intimidate you anywhere. I believe you understand the theory of Charles' law. Let me quickly go to the general gas law. Okay. So for the general gas law, it simply tells us is just the combination of the Boyle's law and Charles law. What is Boyle's law? Okay. What is Boyle's law here? Boyle's law explains that volume is inversely proportional to P, okay, at constant temperature. Temperature is constant here. Then what is Charles law? When you combine Boyle's law and Charles law, you'll be having the general gas law. So that is explain that volume is directly proportional to the temperature at constant pressure. Pressure is constant here. Okay, if we call this equation 1 and we call this equation 2, okay, let's bring equation 1 and 2 together. When you bringing equation 1 and 2 together, okay, what you are going to have is that this is volume and this is volume. It explains that the same volume of the fixed mass of gas with the sign of proportionality is the same, okay, and this is 1 over P, okay, times T. Okay, then you are going to have volume directly proportional to what now? T over P. Do you understand? So if you introduce the sign of equality, you are going to be having V is equal to what now? KT over P. Do you understand that? So with this, you are looking for K. Then you are going to have PV is equal to KT. Okay, by the time you make so with what you have now, you are going to have K is equal to PV over T. And because it's constant, it will be P1 V1 over T1 equal to P2 V2 over T2. I hope this general gas law, okay? The general gas law is this, which explains that PV over T. Finish. So with this, you can solve any question. Okay, but before you begin to solve question, I'm going to give you some conversion factor that will be peculiar in this area of physical chemistry. So look at this. Okay, so just have this in your mind that 1 liter is equal to 1,000 mil. Oh, okay, which means 1 mil is equal to 10 raised to power minus 3 liter. I hope this is not confusing. Okay, you can also say 1 liter is equal to 1,000 centimeter cube. Okay, and one atmosphere is a unit of pressure. Liter is a unit of volume. Milliliter unit of volume. Okay, so 1 atmosphere is actually equivalent to 760 millimeter of mercury. It is also unit of pressure, okay, which is equal to 760 torr. Okay, this is also unit of pressure. Okay, then also that 1 atmosphere is equivalent to, as I said, 760 torr. Okay, so which is also equal to 1.01325 times 10 raised to power 5 Pascal. Okay, this one is simply 101325, okay, Pascal. Okay, I hope you understand that, and you should know that 1 Pascal is equal to 1 Newton per meter square, which is equal to 1 kilogram per meter square. Okay, okay, in its in the new nomenclature, okay, format. So just have this, and there are other conversion factor I will be bringing your way by the time we start doing some calculation. I'm going to produce a video that will just it will be strictly on calculation, okay, of the gas loss. Do you understand? So I want you to just show a kind of like to my video, and then also subscribe to this channel and share to others. Put on your notification button so that whenever I upload a video, you will be notified. Thank you for watching. Thank you very much. But shortly before I stop this video, I forgot to tell you that you can have a conversion of degrees Celsius to Kelvin, okay, and from Kelvin to degrees Celsius. This is the equation you will use for that, and also to convert degree Fahrenheit, okay, to degrees Celsius. Okay, you can use degrees Celsius is equal to 5 over 9 into the bracket of degree Fahrenheit minus 32. We shall be using this conversion factor later as we solve calculation. So just know that this conversion factor are possible even from here. By the time you convert degree Celsius to Fahrenheit, okay, from degree Celsius to Fahrenheit, or from Fahrenheit to degree Celsius. For example, you are given 15 degree Fahrenheit, you will put the 15 here, then whatever you solve here gives you in degree Celsius. So from degree Celsius, you can convert to Kelvin. Okay, do you understand? So, but in my subsequent video in calculation, you will see some of these things. Thank you.